Hello, welcome back to another episode of the Reliability Gang podcast. I'm back with my right-hand man, Will Crane. How you keeping, Will?
I'm doing very well, thank you very much.
Brilliant, guys. Thank you so much for the response on the Chris Hansford podcast.
Oh, it went down like a treat, didn't it?
I mean, a lot of people are saying, how did you actually manage it, Will? How did you get Chris on there? But I think he really enjoyed it. Like, the reception from him, he was definitely radiating some sort of energy on that podcast, and we got some real humbling, nice stories. So thank you for everyone and their feedback with that podcast, and thank you for everyone with the feedback with the videos and the new content going on to YouTube and all of this new stuff that we're kind of creating. We want to try to get you into our world as well a little bit in terms of the Reliability Gang. We really feel like we're building like a culture and maintain
Bit of a community.
Yeah, a culture and community with the Reliability Gang, and it extends further out than just our people. It really does. I think we're really kind of communicating with loads of people across the world. This is the thing I love about what we do. It's the fact that there's so many people from different countries, different cultures that have the same love for reliability, and everyone comes together. And the beautiful thing about LinkedIn as well, some of the case studies and stuff we share, we've got so many different diverse peoples, different opinions, different people that have been through different experiences as well. So thank you. We're grateful for the Reliability Gang. I just want to say that as well. Our journey has kind of been incredible this year. And today we want to talk about reliability, don't we, Will?
Yep, definitely. No, we want to have this kind of podcast, guys, is really focused on our journey in terms of reliability. So for those that have only probably been listening for a little while, when I joined Will at Maintain, at the time we were Maintain Condition Monitoring, or Maintain CM. And very quickly, as we were going down that journey, we realised that as a condition monitoring company, all we were ultimately doing, we were adding value by identifying problems that could potentially reduce or cause unexpected downtime, but ultimately we were giving customers a lot of problems in the meantime that they were struggling to deal with.
It's always a trouble. It's always the case with that type of thing, because notoriously, again, sometimes like the wrong way to kind of put value on our value is giving people problems. Does that make sense? So by saying, oh, we are finding you all these different things, is not really a metric on how valuable your service is, if that makes sense. Because essentially, who is actually receiving that information, you have to put yourself in them shoes. And we know even now it's so difficult for availability. Resources are tight. And again, every place is the same to a degree. And if you're getting more problems on your plate, do you know what I mean? Are they necessarily helpful? I mean, obviously, they're obviously important, but as well, the more you put on the plate, the less like severe they seem, because you've got so many on the plate.
Especially the smaller customers that we have that are not, at the larger scale, where they have an abundance of teams that look after this and look after that. You often find that the engineering manager isn't just responsible for engineering, he's also looking after compliance and looking after this. So he's got a lot of other stuff on his plate, let alone having us come in and be like, this is broken, you need to change this soon. Can be quite overwhelming, especially for new customers that we've never been to before and they've never experienced condition monitoring before.
Definitely, and this is kind of where the business model spurred, because again, I think obviously when I started this business, it was almost a copy from what I did before, essentially, because you kind of take what you know and then you try to improve it or make it better. But in terms of the strategy and the model, it was very similar. Do you know what I mean? In terms of going in, doing vibration analysis, selecting a bunch of assets essentially and giving a good condition report on them assets in terms of what we find. Do you know, regardless of what the criticality is, regardless of a lot of metrics that at the time weren't measured really to the degree that they should have been. Because obviously at the time, again, you have the verbal discussions in terms of plant. Of course you do. The engineer manager knows kind of verbally or off his head where the critical assets kind of are and what ones can hurt them. But again, a lot of the time, I'd say a very high percentage of the time, there's not been enough criteria behind them decisions in terms of what actually is critical and what's not. And because them criticality assessments hasn't really been thought at a level of getting everyone involved around the whole organisation within the business, generally the criticality then usually is only kind of assigned to one person's perception rather than actually it being critical, if that makes sense.
Yeah, definitely.
So again, we found that it's not a problem, but obviously as we are going through...
It's an awareness thing, I think it boils down to. It's like, even for us and our journey, because obviously after we made the transition over to reliability, we included the solve part where we do a lot of the engineering services, but that's where the improve bit kind of stepped in. We're like, right, reliability, we were just coming out of COVID. Customers were looking at more, how do we build a bit more of a strategy? And I don't think reliability necessarily, it's not new. It just, for us, I feel like a lot of our customers are just now coming onto that part of the journey.
Yeah, I agree.
And we did as well. So we kind of were like,
we kind of pivoted, didn't we, off the basis of the industry kind of requiring more than just detection.
Yeah, I think, and like for us as well, like we've always been around reliability. We understand that condition monitoring as a whole doesn't improve reliability, but helps find these problems. But there's a real big synergy there. So we kind of felt, well, we had a chat, didn't we? And we were at the time just then getting more involved with Mobius training, and Mobius offer a course called ARP. So we're like, right, we're getting more involved with reliability. We should probably at least get ourselves trained to understand the real nuances of it.
Of course. And obviously, in terms of your experience in your previous jobs, you kind of sidestepped out of kind of the condition monitoring role a little bit and went into more continuous improvement and kind of looked at more of the production values, which I think is helped us massively, because when you're just so engineering and you're not really in the production world, you can't really comment in terms of how things are done and how things are run.
Yeah.
Because these two departments, essentially, they need to be able to communicate. Yeah. And I think this is probably one of the notorious problems that we probably still currently have in the majority of the UK, is where the communication could be a lot better or improved.
Yeah. And I think like reliability as a whole, as we're working with customers now that are creating their own reliability departments, or we're there supporting as the reliability, support, you start realizing that reliability is almost like a bridging group, because you're trying to improve the reliability to make sure production are happy and they're producing. You're trying to improve the reliability to make sure the quality team we're making the product at the right level of quality. We're trying to make sure engineering are happy and health and safety. And this is why reliability can have such a massive impact on an organisation when it's implemented. It can be
like the glue, can't it? To be able to glue things together to a degree.
Yeah,
because there's a lot of separation, I believe, and a lot of whenever you're in any organisation, I think there is, depending on different sectors or sections that have different kind of roles, there is segregation to a degree, but then the reliability part almost glues it all together, so they all kind of understand each other as well. And I think there's a bigger kind of benefit to do reliability on the communications parts of any organisation in terms of a positive impact than just purely from the metrics it can drive and save you money in terms of the long run as well. So and again, I think your experience within that world opened up my eyes, because obviously I was very interested in this, always have been, but never really had the opportunity to go on a course or go down the right route to be able to give us the awareness of what actually is reliability, really, because it's just a word that's thrown out a lot of the time, and what we're about to do is really kind of hone into that word. What does it actually mean? Right, what are the functions behind it, and as well the awareness as well to be able to, where do we go learn this information? If you're not actually kind of exposed to it at school or college or anywhere on your educational journey, how do you actually come across it? Because you either come across it when you're working at a company, a bit like you did with the CI stuff, and you kind of learned as you had a mentor there that kind of taught you the ropes, or if not, you kind of learn off your own back. Yeah. So again, this is where I think ARP for us is so important. It's so valuable, because I think you've now gone through this process as well, haven't you?
It just changes the way you think about stuff. Even as if you're, a engineering manager or your maintenance manager that is aware of reliability, it can be, you may have KPIs that are telling you, right, we want to improve the site reliability, but where do you start? And I always felt that, or coming off the back of doing my ARP, what it gave me was, it gave me a framework of, okay, well, how do you start this? Like, okay, I'm a factory manager, I'm an engineering manager, I want to improve site reliability. How do I do it?
Yeah, where's the steps?
Where's the
first point on the first step in the ladder?
Exactly.
And I think sometimes it can be overwhelming, because I think when people break down the reliability kind of services and the different things that you can kind of get as a service down into little chunks, it get quite complicated kind of. There's a lot of different things, a lot of different words. There's a lot of different, and some of them mean similar things as well, so it can be a little bit confusing. But what ARP kind of does, it puts it all into a place where it's all understandable and it's all really process driven. So you're like, from the start, you don't need to know about a lot of the stuff at the end of the course. You go through it in this process way, which I just think is really, really valuable for anyone to get grips with. So if anyone is out there, okay, and they're in a reliability role, and obviously, again, it all depends on experience and where you've been in different, because again, you could have been somewhere where it had, great experience with it, and you could kind of know everything that's within this content. Conversely, you could be somewhere that hasn't really kind of done that. So the course has a lot of value in that sense. So let us guys know if you are interested in it, because I believe this course is going to blow up in the next 5 years, definitely. Purely because now we're ready in this time of place where reliability is now coming into its own, and a lot of people now are looking to be able to get actually accredited for, you know, doing it and understanding it as well.
I think if you're in a situation where you've got a piece of machinery or an asset that's very critical to you, and if you're asked the question, how do you maintain that asset? And then you list out all the ways you're maintaining it. And then if you ask yourself, why do you do that? And you can't answer that, then reliability is a very good opportunity for you to get involved with. Because if you're maintaining an asset through this ways and you don't really know why you're doing it, the reliability journey as a whole will give you a framework to be able to say, well, this is how we're going to maintain that asset and why we're going to do it.
And the why part is probably more important than the how, essentially, because
yeah,
what's the point in doing something if we don't even know why we're doing it?
Yeah.
Does that make sense?
It's a big part, like we see even now with just the customers that we do condition monitoring with. You know, we're going in, they haven't done the reliability part, so they don't understand. They understand why we're doing condition monitoring, but they don't understand why that helps them avoid certain types of failure modes. So what you end up finding is we do the condition monitoring, someone walks around and checks the asset, someone does this PM, someone does that PM, and then you end up with loads of PMs that probably could be removed because we've decided that these failure modes are being covered by this maintenance strategy.
Yeah, of course. And again, that's the thing. This is the thing what is so valuable about it. Because if you can save time and resource, right, when it's very limited, right, over loads of small little places,
Yep.
okay, it adds up catastrophically. And this is the thing about what people need to understand in terms of efficiencies. If, you know, when you've got a lot of PMs being pumped out and you can get a little bit efficient with one and alter the way you're doing it because you're doing a bit of condition-based maintenance as well, and you've got a mixture, then it can really start to, you know, play massive benefits for your maintenance functions, especially your availability as well.
Yeah.
And then you can then get proactive, because the problem is it's this maintenance cycle, isn't it? It's this reactive cycle. You can't get out of it.
No.
It's impossible
It's
if your
difficult.
guys can't spend time on being proactive.
Yeah.
Do you know what I mean? If they're reacting all the time, then how can they be proactive? How can you have, like, obviously you've got strategies to become proactive, but if you've got no one to do that proactive work, do you know what I mean? Like lubrication and making sure everything is running in a nice, you know, way in terms of running conditions to precision. You've got no time for that, because that stuff takes a lot of time.
Yeah, and that's where
Yeah.
you're kind of like FAMICAs and RCMs come in and PMOs come in. So these are like a few acronyms that are thrown about in reliability quite a bit, and they're part of the ARP course. So FAMICA and RCM are there to help decide what the maintenance strategy should be for those assets. And we can go in more detail with that maybe in this podcast or another one. And then PMO is to look at your current planned maintenance and which ones are not worth doing.
Yeah, like a kind of
Get rid of the
get
ones
rid of
that
the ones
are
that are just not
doing,
worth doing. Yeah,
and
yeah.
then your FAMICA and RCM help you look at on each individual asset or system, what should we be doing?
Yeah, and what strategy is best as well in terms of that.
Yeah,
What
and
should
it just looks at, we're just doing basically a risk assessment on that asset based on all the different failure modes that could potentially stop it doing what it's designed to do.
Yeah.
So that's all we're doing in that part. And when you break it down like that, it becomes a little bit more simpler. I think they, like, when you have these big acronyms, people get a bit,
They do, yeah. I think they,
like, oh,
they get a
God.
bit off by it, don't they?
And
It
FAMICA-
sounds complicated. It sounds much more complicated than what the actual function of it is, if that makes sense. To be honest, a lot of reliability stuff is the idea is simple. And because it is, it's efficient.
Yeah.
Again, like, what we don't want to do is overcomplicate stuff. We come from a very complex world of vibration analysis, where a lot of different terms and terminologies and numbers and, you know, different ways of calculating things. When it comes down to reliability, we want to try to be as efficient as possible, don't we? We don't want to be really. It's no analysis by paralysis. It's knowing when to be efficient and what practices to use in organisation to make things run smoother.
I think it's generally for both vibration analysis and reliability, and engineering in general is, as engineers, we like to overcomplicate.
I know we do.
things. Like,
And like, how many times as well you're like, and again, this is one of our biggest drives as well, and it's kind of almost me. I was almost conditioned years ago as well in terms of being an analyst. You know, I loved it. I love the art. It's like an art, vibration analysis. And it gets very disheartening when you're like, my art of showing into this report of like the spectrums of time, waveforms and all these beautiful things and these different curses and the explanation of what's going on and why almost now becomes redundant.
Yeah.
And it's a pain. It's like a big like knife in my heart, because I'm like, the customer doesn't need to see all of this information. Okay, it's great, and it's great that I've done that as a study. Maybe for another vibration analysis engineer, the engineer manager, he don't care. He doesn't care if it's inner race, outer race, whatever defect, and seeing pretty plots and stuff. He doesn't. That's not what he is passionate about. If that makes sense. Yeah. What he is passionate about, though, is running his plant efficiently. So he wants to see that information in the most clearest way, and the most simplest recommendation in terms of how do I get it here, and then what is our job to be able to say, do you know what, actually, we can actually do that for you. We can actually solve that for you, and we can improve it if you do it like this. So again, what we're trying to do is we understand how busy people are. Do you know what I mean? In terms of their day, what we want to try to do is not give more problems. We want to try to help them out and try to get them to the next stage of where they can actually start implementing these strategies to become more reliable. Because if we just carry on giving people recommendations all the time, then we just kind of in this perpetual loop of insanity to a degree, because it's just nothing ever really seems to change, does it? No. There's no improvement. And I think us as engineers, we have this innate want to be able to make things better and improve. And eventually, no matter how much you're doing something or detecting issues, if you can't see the improvement, you will start to get demoralized by that. Do you know what I mean? Because it's just the engineer's way. That's what I personally feel like anyway, when sometimes things are moving, not slower, but maybe things are just kind of at a standstill with no strategy to be able to say, well, where are we going now? What's the best, what from this point here, how do we actually improve what we're doing? Do you know what I mean?
Yeah, and I think reliability as a whole, or the ARP framework or anything like that, it just gives a base of where people need to start. So like stage one of the reliability kind of like journey that's outlined by Mobius talks about culture change, buy-in, business plan, business opportunity. It's about looking at what opportunity is there to improve the reliability, and where to start. That's like the first part of the course.
How important is that first step in the culture change in terms of getting the whole program to actually work as an oiled machine and work? I mean, how important is it? How integral is it?
Basically, like, not to hamper down, like, not to, I'm trying to think of the word to describe
give me your honest opinion.
Essentially, if that piece isn't done, you're kind of destined to fail.
Really, it will not work.
Pretty much. You have.
Why is that?
When it comes down to reliability, it's one of those very few things that is influenced by so many departments within the business.
Yeah.
So, it's influenced by the purchasing team. It's influenced by health and safety. It all has this impact on a widespread network. Therefore, it's imperative that there is at least buy-in from above. That's the first step. Like, if you're just the engineering manager, like, you have to get, the directors on board. You have to get the shareholders on board. If you're a big enough company, say, look, we are going to make a big change to the way we're doing things to improve our shareholder value, to improve the way we do things, to do this. And it has to come from, if you're not at the top, you have to present to the top.
And
so
you have to make the
down.
why big enough as well, so people listen. And I think that's what a lot of people are missing as well. A lot of people want to do reliability, but they don't know what their why. They don't know really what is it going to bring to their organisation. What efficiencies is it going to bring? And once they understand what them whys actually could be or are, then it's a lot easier to sell that to anyone. Because when you really know the value of what you're doing, it's quite easy to associate a cost to what the cost could potentially bring you back in terms of return on investment as well.
And don't get me wrong, like, there's ways you can improve the reliability of your plant without going and doing this massive reliability project and culture change. You could do little things like trying to improve the lubrication and stuff like that. But if you want to make a big impact and change the way that the entire business is ran, it has to go for the top first.
And I think that's why kind of an ARP stuff that really opened up my eyes and your eyes as well. Initially, that was the first kind of part of the course, because again, if you don't get that bit right, it's very difficult to really implement it, in terms of longevity and something that is going to be able to have a legacy as well.
It kind of opened our eyes up as well from our angle as well. We don't just teach it, we go in and look to support and implement it. And often what you find is that in organizations where we see lots of opportunity for improvement with reliability, if it's not being, and a lot of the cases not, if it's not being measured as a KPI for like the engineering manager, when we're speaking to him being like, look, we need to improve the reliability, let's see if we can get the plant running. If he's not being measured against it, he doesn't care.
He doesn't. That's the thing, isn't it? As well,
we then end up realising we're going to the wrong person. We want to go up to like the directors and be like, look, you have an opportunity here to improve the quality of the product, make more of it, make more money. But we have to change the way that
exactly, because it has to be fed from the top, doesn't it? Because at the end of the day, we can be kind of talking to the engineer manager about these things that are essentially going to give more life cycle to his assets, but that's a long game for him. He's not thinking of the long game. His KPIs are driven upon the short game.
Yep.
So he's not really interested in that. Well, he's interested. I'm not saying that. I think every engineer is interested in terms of that, but like it doesn't really benefit his short game. Do you know what I'm saying?
Yeah.
Which is getting driven on them KPIs. So again, them KPIs and a lot of them figures are being driven from the top below.
Yeah.
So again, this is why it's very important to be able to really get, from the top down, really, a good buy-in and understanding of how this works. And that can be difficult for companies like us because, when we're growing into this, we're kind of far removed from that top level kind of people. We kind of really, our whole world is based around engineering managers, so to speak. So it kind of pivots the way that we have to approach it as well. And kind of pivots the way that we have to almost have these podcasts because, again, we are talking to a lot of engineering managers a lot of the time. That is kind of our audience and kind of a lot of people that follow us, are in that world or in reliability. But we have to start looking at the other people as well and communicating this message to them as well because, again, they're not going to be necessarily into this engineering world like, the engineering managers are as well. So
and it also boils down to we have that very good relationship with the engineering manager, and sometimes we can't get above to the people above.
No,
that.
It's difficult.
So we're reliant then on site to be able to push the message that we know they need to do
up the scale. Exactly.
And so we're very fortunate at the moment. We're now going through a big reliability project with one of our customers, PPG, and we work very closely with Nathan there, and he's really on board with what we're doing. So the other week we put a presentation together, and then just outlining very briefly what the opportunity for improving the reliability for the site is. And he's now presenting that this week to the guys above him to say, look, this is what I want to do. This is why I want to improve reliability. This is how it's going to improve our regulatory compliance and stuff like that, which is one of his KPIs.
Yes, one of the big KPIs.
Because they're a chemical co-material site. So he's now presenting that, and if he gets buy-in from it, it's great because then we can start. Then we start the process of moving down.
It's like having that win before you've even done any work, because when you get that buy-in, then every action after that, it's going to be well received, and they're going to get the most value out of your time in terms of what you're doing.
Especially when you're trying to change something that maybe people are a little bit resistant to. You're like, no, we're changing it because of this.
Yeah, and you always have to really promote that message from the get-go, because if not, it's going to get lost in translation. Because there are a lot of changes that come with this kind of reliability roadmap, especially when it comes down to old ways of maintenance in terms of kind of more habitual ways of maintenance that are not necessarily working. And outdated ones as well, where a lot of these processes have been put in at a time and place where technology wasn't available. Do you know what I mean? We didn't have the actual capabilities to be able to detect a lot of these things as well. So again, PPM kind of was driven a lot more back then. But what I found is, as we've had the technology, we've implemented more condition-based maintenance. The PPMs are still there; they're still staying. They're not shifting or evolving with the plant as well. So again, I think the one at PPG for us is beautiful, because we've had that contract for. I had that when I was on my own, if that makes sense, and we did incredible work there in terms of vibration analysis and condition monitoring. But when now the questions are being asked about how we can get to the next level, we've got great buy-in from Nathan and Sai, and it's an exciting time actually to be able to do it as well and work with the guys, because we've almost evolved together through this process, if that makes sense, and we're ready to be able to offer these services now. And this is why I'm so proud of this year in terms of maintaining reliability, and yourself, Will. We've really kind of transformed into something different for the better. Do you know what I mean? And by doing that as well, we're not trying to obviously drop the ball or get any worse with the other services. If anything, they're becoming better because we're being more efficient. Yeah, exactly.
Because now,
it's a different focus as well, isn't it? We can offer that now in terms of not even shove it down people's throats, but just start giving them the awareness to it, and then gradually it can maybe grow into and evolve into something that's going to help.
It's not just anymore about us turning up to site, mapping all the assets, collecting the data. It's about asking the question, why?
Yeah. Where's the journey now?
Why are we collecting this asset like this? Is there a better strategy to do it? What else are you doing to the assets to maintain
How can we help you come up with them, them decisions as well? Do you know what I mean?
Kind of with that first stage, we've got that buy-in from above. It's then important that we get buy-in from below as well. Exactly. So that's the next part of that kind of part of the journey, which goes into
that's where passion as well is extremely important. When you're very passionate about these subjects and you're trying to be able to get like-minded people within engineering sectors, because again, that bit is for us a little bit easier, I find sometimes, because it all depends on kind of where they're at in terms of age and where they've kind of, you know what I mean, being within the organisation. Because, you know, even when we was speaking to another company and they had a couple of graduates, they were well for everything we were doing. And it almost seemed like they were straight off the bat, yeah, this is great. It sounds great. Yeah. So for them, it was a bit, because they're new to the industry, they're coming into this reliability game right now. It's a game changer for them. Because remember, if we had the same exposure to reliability when we was coming up in our graduate years, imagine how much we would have learned already. Do you know what I mean? Opposed to kind of learning it in the last kind of 4 years of growing this business and kind of going to where it needs to go. So, yeah, the reliability stuff and you know, the stuff we're doing at PPG is really exciting for us. And it's great to be able to, you know, work alongside these companies that have been very close to us for a very long time in different ways as well. Do you know what I mean? So in terms of reliability, well, let's just quickly go over some of the things that you've learned. Yep. Maybe pick 3. I think we've got enough time for 3 little things that you've learned in the ARP or your reliability journey and why they're important.
Okay, understanding what failure means. That's quite an important one.
Understanding what failure actually is. So Will's got a great little discussion about
this. Actually, I had a good little discussion with Danny on LinkedIn about this the other day. He put a comment out. Jamie put a video of a bearing. You may have seen it. Bit of a ball counter.
A lot of people, I shared it. A lot of people see it. And it was a shocker. It was a shocker.
It was a beautiful find, but the shaft was still running. And it probably had about 4 balls in it. It should add probably 12.
And it was literally just like one of them little carousel balls was just coming over and just ticking round ticking round. So 4 balls were keeping this thing going. Literally hanging on by a fingernail.
When, in terms of like reliability-centered maintenance and the FAMICA process, RCM in particular, we have to define the function of the machine to be able to understand what are the ways that it can fail and what are the effects that happen if it fails and the causes and consequences and everything like that. So for that particular application, it's a screw. It's a
screw conveyor, isn't it? Moving products
from one place
A to B
to another. So when we look at RCM and FAMICA, we're talking about, we want to understand how the machine can functionally fail. So for a pump, for example, we may state that the function of the pump is to pump fluid from tank A to tank B at set flow rate, at set volume, whatever. Now, if the impeller is worn and it is no longer delivering the flow, we would say that it is functionally failed. It's no longer performing its function.
It's no longer able to perform the function of what it's supposed to do.
It's still rotating.
But it's still moving. Yeah.
So in the case of this conveyor, the function of it would be to move product from A to B. The bearing may no longer quite be integrally sound, but the function of the conveyor is still there.
Actually happening. He's still actually managing to get product from A to B.
So you could say that the conveyor has not yet functionally failed.
But
however,
the
bearing
has failed.
What is the function of the bearing? It's to provide support to the rotating element of the shaft, the motor, whatever. You could argue from that video it may no longer be providing the support necessary to take the axial load or the vertical load that is required, and therefore for the bearing element that has functionally failed. It's no longer.
And then you could even put another curveball in there, because you could say the cage is a part of that bearing.
Yep.
Has the cage functionally failed? Because the function of the cage is to keep all of the balls in
and everything that we're kind
of to the bearing.
Yeah.
And is it doing that? No, it's not, because the cage is not even there. So the cage has functionally failed because it's not doing the cage's function for that bearing.
Yeah. And this is like...
So this can get a bit confusing, kind of.
It can do, and this is where like your FAMICAs and RCMs come in when you're going through all the different failure modes. This is where you have to decide, and it's part of the process of improving reliability, like how far do we go? Because
at what point does it get a little bit...
It's what's reasonably practical. NASA probably wants to know all the failure modes that are going to stop
down
the cage.
To the T in every single little detail.
You know,
but do we need to when you're looking at them kind of functions of a, shall we say, a bearing? Or
exactly.
Something that is fairly simple in its operation.
Even for a conveyor, you probably won't start listing all the failure modes of the bearing. You probably won't go cage, outer,
the bore.
inner. You probably won't. But what you do want to understand is, you know, what is going to stop that conveyor from performing its function? It's going to get blocked. That's one thing that might stop it from delivering from A to B. The bearing may collapse and fail.
The shaft may fail.
Exactly.
So anything that actually physically stops that process or function
Yeah.
from actually happening.
And that's
being
the first
achieved.
thing, for me, that was one of the first, understanding failure a bit. Like, when do we class it as failed? Like, when is it stopped? Is it when it blows up, or is it when it, stops doing what it needs to
Exactly, 100%.
do?
And
That was a cool learning, thing.
yeah, and I like that as well, because I think it gives a good kind of debate as well about, has that failed or has it not? And is there different words we can associate to failure, like functional failure, right? Should we start using that a little bit more? Because it means a lot of different things to a failure.
Yeah.
Does that make sense? Has it actually caused the function of whatever it is to stop? Do you know what I mean? Because you could have a pump and you could have a motor connected to a pump. And the motor may have failed, but the pump may not have failed. But obviously, because now the motor's not turning the pump, then the pump's not going to be able to do its function. So it's a functional failure, but the motor has failed. So again, you can kind of almost define failure as different kind of criteria in itself as well.
Yeah.
Well, all right. Well, that was a really good example. I actually really like that discussion. Give me one more. Actually, no, two more. I want two.
You want two more? Okay. Trying to think. I really like the breakdown that is taught in ARP in that FAMICA and RCM risk assessments, essentially. I think it really mystifies out what could be quite a complex process.
So FAMICA and RCM risk assessments.
Yeah, to a degree. So they're both different strategies that help you define what maintenance needs to be done. RCM is one way. Failure mode effect criticality analysis is another. But all you're essentially doing is you're looking at the function of that asset and you're trying to work out all the different ways it could stop doing its function.
Yeah. Which one is that? Is that the...
They both do a very
both do the similar thing. Okay,
thing. They're just structured slightly differently. We're listing all the different ways it could potentially stop doing it. We're going through all the different causes that it could stop.
Give me an example,
or
mate.
effects.
Give me a bit of an example. Like, I don't know.
Okay, we've got a water pump.
Yeah.
And it's got a pump flow from A to B at set volume. I like to use this analogy because it's quite good, but you could say, okay, one of the ways it could stop performing its function is that the pump casing could crack.
Yeah.
Right? So what FAMICA and RCM do is so if that was to crack and fail, what would be the effect? The effect would be that the pump loses all the water out.
And it cannot pump the water.
Can't pump the water.
Because there's no volume to hold.
Yeah, so you look at the causes that could cause that to crack as well, and the consequences. So if that was to crack, the consequence would be we'd end up with a puddle of water on the floor.
Yeah, or the consequence could be a lot worse if it was a chemical product. Or
exactly.
something like that. So then that risk then becomes a lot higher
exactly.
because of that.
And that's where things change, because you look at it from two different angles. So you say, if it was water, the effect and the consequence would be, the effect would be we won't be able to pump water anywhere. The consequence would be we end up with a puddle of water on the floor. The likelihood, which also gets factored in, and the detectability, like how likely are we going to be able to this to happen, and what's the detectability of it? To detect it, it's pretty hard to detect. If the likelihood of happening it is quite low. So on a water pump, you may say, well, as a business, we're happy to accept the risk that, yes, okay, we may end up with a puddle of water on the floor, but the likelihood of that happening is quite low.
I think when you've gone through that kind of process, then it does start to think, okay, I really now can define really what I need to worry about and what I don't.
If it was a chemical pump, the likelihood of that happening is still very low,
but the consequence is
huge.
High. It's massive. Yeah,
so
exactly.
As a business, we're not willing to accept that. We're going to bund the pump. We're going to thickness test the pump every so often if it's quite a large cast iron pump.
Perfect analogy, that.
And you just do that for all the different ways.
And that's a great example,
fail.
really, to just give you an indication that, we're not basing just criticality on if it stops. Yeah. Right, there's a consequence to a failure with everything, and that consequence is going to have a different severity depending on what it's pumping, what it's doing, the process, the application, all these different factors. So until you do these studies in terms of FAMICAs and risk assessments that you've got, you will never really understand the severity of the failure if you don't think about it and you don't really kind of almost play it out in your head of what potentially could happen. Do you know what I mean?
And off the back of that, you obviously do it for all your different things. And at the end of it, you're like, okay, well, the motor could fail because of this, or the windings. Well, what we're going to do is we're going to do condition-based maintenance on that. And at the end of it, you have a list of actions and things that you need to do to be able to maintain that asset reasonably to prevent those failure modes.
Yeah, of course.
And that's what then helps you define what you need to be doing. You might need to put some PMs in place. You might need to have someone come in and do vibration analysis
Exactly,
on it.
and that's a really good way of defining the maintenance strategy that is based upon these different facts of what you've got.
And then I suppose for your third one, we could talk about, which ties in quite nicely, which is what we spoke about earlier, which is PMO, which is planned maintenance optimization.
So what's that PMO, planned maintenance
optimization.
optimization? So just explain that a little bit.
Very simply, your FAMICAs and RCMs define what you should be doing.
Yep.
And your PMOs define what you don't need to be doing. So you go through your current list of planned maintenance, and essentially you have to be a little bit brutal. But if you find that the PM does not add value,
you get rid of it.
You get rid of it.
You literally go through that process, and it's almost like clearing out your wardrobe.
If you've got
say if you've got a wardrobe full of clothes, right, and you're like, don't wear that anymore.
Yep.
You have to be savage with it, and it's same thing with this kind of PM optimization.
The amount of resource you may then become available for, if you've got PMs that say check the pump, and you can't answer detailing what they're checking, and you go to your engineers and you say, so this PM says check the pump, what do you do? We just look round,
just kind of feel it, and
you're not adding any value, you're not logging anything of it. What's the point?
What is the point if there's no positive outcome of checking a pump? Like, there's got to be some sort of metric out
if we've determined from the FAMICA that actually we need to check the oil level, we need to make sure that the thickness is adequate, and we're going to do that every 6 months, we're going to check the belts, and it's defined within the PM.
Clean the motor as well, smart PMs as well.
And it's defined in there. Check the you might have check the belt tension, right? It might be a shutdown check or something like that. And it says check the belt tension should be this amount. If it's more than this, we need to raise a corrective. If it's less,
we need to raise a corrective. Yeah.
If it's between this band or whatever, we have to define to the guys exactly what they're checking. That's when PMs become smart. They become effective.
Because when they're checking something, it also gives the guys a metric, and then they actually feel like they're doing something of a value as well. Yep. That's as well a big issue, because a lot of the time when we do get these PMs, they're not descriptive and they're pretty much useless. The guys almost feel like, oh, well, I'll do it, but I don't feel like I'm adding any value. As engineers, if we do not feel like we're adding value, we get demoralized. We have to be able to be kept on our toes to a degree, but as well given actions that are based around actual improvement to the plant, or that is valuable. Because if we're being told to carry out pointless, PPMs, it's almost like saying that you are not valued because we know that they're not good, and we're giving these to you to almost waste time.
I suppose on the whole efficiency thing, and talking about FAMICA and RCM and talking about PMO, I think a last one to kind of wrap it up, because it just came to me, which is really good. So you may do your FAMICA part on a piece of equipment that, no matter what the failure modes are, the effects and the consequences, no matter what, really don't affect production. They're not going to hurt someone. They're not going to do anything. The cost is pretty low. They have no impact whatsoever
onto the business. Yeah,
it's okay to have run to failure. Run to failure is a maintenance strategy.
It is a strategy,
and it's important that that's done, because what you may be doing is you may be having people doing PMs. You may be having your vibration analyst team, or you may be having your contractors come in, test that asset every month. You're putting money. Vibration analysis isn't free. It's a cost implicated.
It's a big cost
on that asset.
It is, yeah.
And therefore, but to the business, that asset, if that was to fail, it has minimal impact.
Exactly, but you can only really make them kind of decisions
when you've done that
piece of work. Because the thing is, something may not really be critical to production, but the health and safety risk of something failing, like a fan, is huge. So again, you have to really base, you can't just say, okay, well, if it was to fail, it wouldn't actually have any benefit,
that's where your effect and consequence comes in. Because if this was to fail, it may not impact production, it may not do this, it may not do this, but if it hurts someone straight away, it's not acceptable.
It don't matter, it's not acceptable at all. Really,
but when you've got a machine right in the corner of the plant, it's maybe just a water pump, and if it goes down, it's a quick change, and it doesn't affect production whatsoever.
And with it failing, it doesn't create any harm. It's a very different story.
Exactly, and that's where you can use run to fail as a maintenance strategy. But it's important that we log it and we record it, because when someone goes, "Why is that run to fail?" It's because I've done this piece of work. I've looked at all my failure modes, and none of these impact the business in any way, and therefore it's actually a waste of our time and money and resource.
And we can now spend that time, money, resource in other areas
on things that are more
important and more critical, rather than having a blanket approach across a number of assets and go way too thin on the assets that we need to be spending a lot of time with, and going, spending time and attention on assets that we don't really need to be.
And that's where your criticality analysis, your Pareto analysis, your opportunity ranking and asset health, all these different metrics, which we'll probably discuss in another podcast. This is what tells you where to start those processes. Where do I start my Famikas and RCMs? Because you can't do it on everything. You're going to be there
you're going to be overwhelmed as well, because, I mean, let's be honest, some of the sites that we visit have hundreds or thousands of assets. So where do you start? So the framework is beautiful, because if you really do follow it and understand it, it works.
Simplifies it.
It does work. It does. Again, there's a lot more to it than that. It's not just, a formula that you put in, you do it, and, you get the results. You have to get a lot of buy-in and a lot of different people kind of involved with the process and understand it and, really be a part of it. But, if you can start to influence the people and you can follow this framework, it
can help revolutionize.
It can literally change everything. And this is, I think, why we kind of want to talk about it a little bit more, because I think me and you had wow moments after doing it as well.
Especially for the smaller companies. We do, we work with a lot of big companies that are already powering through this, but we work with a lot of smaller companies that have been doing condition monitoring for the last 3-4 years, but they don't maybe necessarily have the finances to set up a whole reliability team like Amazon can.
Yeah, I know what you mean. And I think as well, sometimes with that, because there's not been a lot of apprenticeships around reliability, and again, we kind of need a lot more reliability engineers that understand this concept now. We are in the shortage, really, essentially. If I put a job application out, do you know what I mean? That we don't.
It's not taught, is it?
That's why, though.
You go to school, you go to college as engineers, you get taught how to maintain, how to align pulleys, how bearings work, and all the hand fitting techniques. I remember one of them was you get taught all this, but you don't get taught, well, how do I prevent the failure in the first place?
It's just not something that is taught. So again, I think one of my dreams for the Maintain Training Academy was to really create something, with some universities and colleges, something that allows us to be able
to... Goals for 2023. Hey?
Yeah, man, definitely. And again, I don't really care how long it takes. It's more of a legacy thing. But I think it's a big part of our next kind of leap in terms of reliability and UK manufacturing as a whole, really, in terms of sustainability as well.
I mean, next year for us is a very big focus from yourself on training and Mobius.
Massive, huge focus on training. This year has been a great learning curve. We are so grateful for Mobius and their patience, and do you know what I mean? Everything we've done, they've really supported us through all of this. So we really want to shout out the ARP course within this. We'll obviously tag Mobius into this as well, because we're not doing this to sell anything. We're doing it because
it's to raise awareness.
Yeah, but not even that. There's a bigger reason. There's a bigger why to all of this. I see it now. I see it clearer now. I see how this can impact the world if everyone starts to implement this type of thing. It's a bigger deal than we actually know.
It's not just about improving the plant reliability, the endless list of things that if it's implemented
as well,
reduced energy cost, better sustainability
is huge. It's massive.
And and
I don't feel I understood the sustainability stuff until recently. And I did a talk at Maintech about sustainability and condition monitoring. When I started to really research into it, and I was forced to because I was talking on it. Because I knew it was obviously, and I knew it had a big impact, but I didn't realise how big impact that was when I started to look into it and start to think about the knock-on effects of how huge it can actually get in terms of saving if you start to apply these things, and and understanding what even just by condition monitoring can do to be able to really improve sustainability by detecting issues and making them better. So I think we've really tapped into that in terms of our offering, because as well as, of course, we want to grow a business. Of course we do. There's a really nice why behind it in terms of, do you know what I mean? Greater good as well, which I think for us it's a cherry on the cake, and especially when you love what you do anyway, when you actually know you're making a difference in a way, and it gives us that extra push to be able to do that as well. Do you know what I mean? Definitely. So guys, thank you so much for tuning into this one. I want to thank Will for all his knowledge on ARP. It's been a good year actually, and it's been a big learning curve for reliability, as well as myself as well. But obviously Will is kind of I think you've taken a special love to it a little bit, haven't you?
Yeah, I don't know, it's nice. I love doing the condition monitoring. I love the vibration analysis.
He does love the V8. He's a geek.
You have to be.
We're big V8 geeks.
The nice thing with the reliability stuff is it gives me that, and I think it will do yourself when we go through it together in the new year, it's that Why am I doing that?
Yeah. And I'm so intrigued by it, and Will's kind of filled me in a lot. So I probably know half of it just by speaking to him. I've been doing the content. So it's going to help me actually when I do. I'm like, yeah, I've already heard about this, and it's just going to be. But I mean, obviously, decision has been made that Will be probably running these next year as well. So Will be the guy who's kind of taking his heart to it, and I'll be the guy that runs the vibration analysis.
There's going to be some crossover eventually.
I think there'll be crossover because I think I have to get involved, and I think you also want to get involved with what I'm doing. But initially, that's kind of how we're going to do it, and we're obviously going to evolve and grow from that point as well. And we're going to start getting some of the other guys involved with some training as well, because we understand and realise that the UK is a big place, and we're right tucked into the east here. So we want to be able to offer this, in different areas as well. So
we're going to be doing some courses up north.
We're going to do some courses up north as well initially, and then get some other guys and key players that we've got within the business to be able to, share what we share as well. They're very excited to be able to do that and step up to that. And we've got some really clever, bright guys at Maintain. The growth has been crazy in terms of what we teach them. But now, even with me kind of, focus on the training, now we can even become better. Yeah. You know what I mean? So guys, thanks for tuning in. We appreciate all the support. Take care.